With this program, I'm going to show you how to do a sloping face on a part. In this case, it's a striker plate for a small vintage vehicle I'm restoring. And the rest of the part has been machined already, leaving just a square block where I want the slope to be. It's left at the actual datum plane height. I'm going to use the slotting program to progressively mill the slope on that block of material. So the beginning of this program we've gone through before. We can see here defining the graphics, and you can see here I've cut and pasted in the tools that I have set already. But in fact this program only uses this one T3. That's the only one. The rest is redundant. Okay. I've also put this set of comments in here, which is all of the different functions that are available that the TNC 155 can perform, and you can see that their assignment, which just means put a number in a register. Addition, where you need two numbers, subtraction, multiplication, division, and so on. They need two numbers, square root, 1, and so on. So we'll get into the heart of the program, and I've written it fairly crudely to make it simple. And what I'm doing here is I'm setting the cutter at where I want the beginning of the slot to be, minus x minus 12. The slot's set in the function down below, but you can see here, this is where I want the initial y position to be, plus 15.5. And then I do this parameter programming. And you can see here it's saying D0, so I want this line here to assign a number. And it's going to put the number in Q1. Now, Q can have, I think, from 0 to 99 after it, so you've got a lot of variables you can put in different memory spaces. You might be able to go higher than that, I'm not sure. I know internally it stores Q108 as the tool radius, so anyway, 99 different variables should be enough for most people. And it's only expecting one parameter, okay, which is just this number here being put in. So it takes the number that's P01, P01 parameter, and it sticks it in Q1. Then it goes off and does a subroutine, a subprogramming. So we'll go down and have a quick look at that. That's down here. It starts here, L20, and finishes there. Okay. So this G74 is a slotting canned cycle. And I'm going to use it to shave the part. The first time it goes in, it will make a slot, and then when it jumps back here, it'll shift the cutter across 1 millimeter each time and create a slot that basically just widens this first slot it's made. But it'll also go a little bit deeper. You can see if you look at what's happening here with these, this is the same, the other end of the same main program. And you can see now P01 is increasing, it's actually increasing by 0.34 of a millimeter, I think, each time. And Q1 is put in this space here in the canned cycle. And P02, you'll see, is the milling depth. So as I shift the cutter across, I'm also incrementing the depth of the slot a small amount each time. So I've also, you can see this P01's the safety distance of the datum face. So that's where it returns to each time when it's finished its slot. The peck depth is P03. It's 1 millimeter. So the cutter comes down 1 millimeter as it needs to. So the total depth could be, starts out at very small, so it'll only do one slot cut, When you get down to 8 millimeters, you can see it's actually going to do 9 passes to get to that 8 millimeters, which it sorts out in the CAN cycle itself. You don't have to program that. P04 is the in-feed rate, but I've overscanned the slot a little bit, so it's out in space. So it doesn't have to drill down that 1 millimeter for each peck with the ball nose cutter. Probably could, but it's probably better practice not to. So I've just made it go 2 millimeters beyond the part each end. It goes to each end and goes down and slots out, so it goes back and forth, milling both directions. So it'll go down at the end of the slot, mill, go down at the other end of the slot, and mill back until it's finished the slot. This tells you how far it's going to move. That's the length of the slot basically in the X direction, an incremental move. This is the slot width, and it's the same as the cutter, so it will only make one pass to get the width of the slot. If I made that 5 or 6, it would rough it out. It'd make extra cuts at each level to get the widen the slot out to 6 millimeters. And this is the side feed rate. So when it's done that, this here is a call to make this function work. G79, you need to actually call the CAN cycle to make it run. When it's finished, it jumps back to the program and does the incrementation until it gets to the end here. And when it's done all that, this L10 is another call to this park the cutter in the tool change position so you can get the part off the machine. And this is the end of the program here. So that's just a quick introduction to being able to make, rather than just flat bottomed millings, you can make a sloping milling, and obviously you can use all sorts of functions to make crude surfacing of the bottom of your cavities and things that you're milling. So I think I'll leave it there.